Hello. Did you know that the U.S. Bureau of Labor Statistics estimates a 22% growth in the areas of software development by 2030? That's a huge development in the areas of software development and technology as a whole, and it's going to continue to be that way in the future. So, hi, I'm James Evans. I'm a third-year student at Texas A&M University, and I'm currently studying computer science. And today I'm here to talk to you about the coding process, the fundamentals of it, and what it looks like in reality. And the way we're going to do that is break it down into three main steps: documentation, development, and debugging. And so let's go ahead and start with documentation and jump right into it. The first thing you need to do is you need to understand the project. What are the goals? What is it going to look like when you finally bring it all together, and the individual parts that entails? And you're going to do that by creating an outline. Now, it doesn't have to be anything specific, but you do want a rough idea of what you want to do, and you can plan this out either on paper or on your computer. Either way works. It'll work. It'll function just the same. Now, I'm going to show you an example here, if I can get that to focus. This was my final project for my computer science class last semester, and this was the planning stage that I drew up for my final project. So as you can see, I broke it down into three main steps, and this was just writing out what I thought the thought process would look like. And I also, you can see down here, my background information where I researched the topic, got help from my teachers and fellow students to better understand what my project would look like, all before starting so that I can avoid costly mistakes in the future. Finally, the final part of this documentation step is pseudocode. You're going to want to create some code that is arranged in a code-like format, but is also in English, so you don't have to deal with the syntactical errors and whatnot and get into specifics, because you can go into that in the later steps. You just want to get your thought process settled out and what your project is going to look like. And that leads us into development. Development is where you're going to actually start coding your project. And when you start coding your project, there's many things that you need to take into consideration. The biggest one is comments. You're going to want to comment your code explaining what it is as it goes along in your own words, because this helps for not only for readability for you, but also for other people. Most likely, coding projects are not going to be done solo. You're going to be in a team environment, and people are going to want to understand your code, and this can greatly help them do that without having to get down into the details, right? So that's a big deal. And it's important to remember when you're developing your code that you want to take regular breaks, because it's very easy to, with a detail-oriented subject such as coding, it's very easy to get down and break down by small little details, small mistakes. And so you want to give your brain proper rest so that when you are coding, you can avoid those and really speed up the process, speed up the efficiency of your project. And that brings us into our last step. And while I say it's the last step, it's really just, it should be done with the second step. It's debugging. And debugging should be tested regularly against your development process as you go along to avoid the interdependency of different parts of the project. And what I mean by that is if you develop a certain part of the project at the start, and without testing it, you move on to the rest of the project. When you finally get to debugging at the end, you don't know where the problem arises from, right? If you run into an error, you're not really sure where that problem was made. It could be at the start, it could be at the end, but if you test it repeatedly as you go along and solve those bugs as you go along, you can be very sure that as you go along, the problem is in your immediate code that you just wrote, right? So it very helps. It helps a lot with that. Also, there's logical errors, and these are pretty much just as deadly, if not worse, than syntactical errors, because it may not show up in the program you're running in the IDE, the Integrated Development Environment, but it will show up in the results of your code, right? So if you wrote something that sorts objects and it does sort those objects, but in the wrong order, well, it wouldn't throw an error, the compiler wouldn't throw an error, but it would give you the wrong answer ultimately, right? So you want to avoid that. You want to make sure that your code is free of logical errors. So I hope that this gets rid of the daunting image that coding can give off, and encourages you to join this growing field. Now that you understand the fundamentals of documentation, development, and debugging, you should have a good basis going forward in computer science. Thank you.